This question is about the equilibrium 2SO2 plus oxygen goes to 2SO3. State and explain the effect, if any, of a decrease in the overall pressure on the equilibrium yield of SO3. So on SO3, and we want to decrease pressure. So what we need to look at is the number of moles on each side. So there are 3 moles on the left and 2 moles on the right. If we decrease pressure, I'm going to actually write my explanation first to decide on what would happen to the yield. So there are more moles on the left-hand side. Decreasing pressure shifts the equilibrium left to oppose the change as more moles exert more pressure. What that means is that shifting left increases pressure. So as a result of that, if we've shifted left, then the yield would decrease. A 0.460 mole sample of SO2 is mixed with a 0.25 mole sample of O2 in a sealed container. When equilibrium is reached at 215 kilopascals, the mixture contains 0.18 moles of SO3. Calculate the partial pressure in kilopascals of SO2. So I'm just going to rewrite the equilibrium. And I am going to then look at what is happening during this equilibrium. So the ratio is 2 to 1 to 2. The initial amounts are 0.460 and 0.250 and 0 products. At equilibrium, it says that we've got 0.180 moles of SO3, which means the change was plus 0.180, which means that given that the ratio is the same for SO2 and SO3, that the change would be minus 0.180 for the SO2, which is 0.280. But because the ratio is 2 to 1 to the oxygen, it would be minus half of that, so minus 0.09. So that would be 0.16. So our total moles, if we add this up, because to find partial pressure we need to find mole fractions. So if we add up the total moles, we get 0.62. So then if we do our mole fractions, we'd have 0.280 over 0.62, 0.16 over 0.62, and 0.180 over 0.62. We only need the partial pressure of SO2, and to find the partial pressure, we take this mole fraction and we times by the total pressure. So if we just go back to the question, 215 kilopascals. So you want to put that into your calculator and you should get 97.1. A different mixture of SO2 and O2 reached equilibrium at a different temperature, and they've given us the partial pressures. It wants us to give the expression for Kp. So this is Kp, so be careful, no square brackets allowed anywhere. We want the partial pressure, so you can use pp or just p, but it's the partial pressure of, and any brackets would be rounded, SO3, that's the product, squared, because there's 2 SO3s. There's 2 SO2, so that's squared, and then oxygen, there's just 1, so that's not. So that's our expression. We're going to calculate a value, so we're just going to put the numbers in. 1.85 times 10 to the 2 squared, divided by 1.67 times 10 to the 2 squared, and 1.02 times 10 to the 2. And put that in our calculator. And if you put all that in, you're going to get 1.20 times 10 to the minus 2. So that's our Kp. And then our units, so we've got pressure squared over pressure squared times pressure. So we've got the units of pressure to the -1, and the units that these were given in were kilopascals. So it's kilopascals to the -1. What is the effect on the value of Kp if the pressure of the equilibrium mixture is increased at a constant temperature? This is kind of a bit of a trick question, really, because the only thing that can affect and constant in chemistry is temperature. So if the pressure is changed, Kp will just stay the same.